We upgraded a model, measured it, found it was 30% slower than the one it replaced, and wrote that down as an acceptable trade. Better at agentic work, worse at throughput. That conclusion was wrong. It survived a full day, and the thing that made it wrong was sitting inside the file we had already downloaded. This is the story of finding it, and of the two tests we were running at the time that turned out to be lying to us. Everything in this video was measured locally, on one machine by one operator. None of it is vendor reported. Where a number is uncertain or was taken under conditions that do not match the number next to it, I will say so at the time rather than bury it in a footnote. That matters more than usual here, because the interesting part of this story is not that a local model got faster. It is how nearly we published the opposite. Here is where we started. The machine was running a 4-bit build of DeepSeek 4 Flash, the April checkpoint at 33.6 tokens per second. DeepSeek then shipped the 0731 checkpoint, same architecture, same size, retrained after the fact, with large claimed gains on agentic work. We switched. It passed a 5 check acceptance gate. Then we measured it 23.5 tokens per second, roughly 30% slower than the model it replaced. And that is a completely reasonable looking result. Newer model, better at reasoning, costs you some speed. You would accept that. We accepted that. What changed the answer was an audit of settings nothing on the machine was using. One of them turned out to matter. Native multi-token prediction, speculative decoding using extra prediction heads that are baked into the checkpoint itself. So we looked inside both builds on disk and counted the tensors whose names begin with MTP. The 0731 build has 4,705 of them. The old 4-bit build has 0. They were stripped out during quantization. So the model we had been running for months could never have done this. The new one shipped a capability, and it was switched off by default. And this is the single most useful thing in this video, because you do not need to download anything to check it. The base model is 284 billion parameters, but the official repository reports 304 billion, and the build that keeps the speculative decoding heads reports 305. That extra 20 billion is not a bigger or better model. It is the draft module. So the parameter count on the model page is a public fingerprint. If a build advertises 284 billion, it threw the draft module away and it cannot speculate. If it is in the low 300s, it kept it. That is a 30-second check that decides whether about a third of your throughput exists. So that is the finding. Now here is the part that decides whether it is worth anything, because a 49% gain is exactly the kind of number that turns out to be an artifact of how you measured it. There were 3 specific ways this could have been wrong, and we had to rule out each one before writing any of it down. First discipline. Our 23.5 baseline had been taken on one version of the inference server. The machine had since auto-updated to the next one, and that release was specifically about DeepSeek speculative decoding and cache handling, precisely the code path we were about to measure. If we had compared the old baseline against a new number, we would have handed the feature credit for a version bump, and nobody could ever have disproved it afterwards. So we remeasured the old configuration on the new version first, 23.1, statistically identical to 23.5. The version was not a confounder, but that could only be said after checking, and the check cost 1 run. There is a second trap here too. The application updated on disk at 9:02, while the server process had been running since 4 in the morning. The running process kept the old code in memory. After any auto update, restart the service, or you are still running the old build and attributing your measurements to the wrong version. Second discipline. Do not assume a feature is running because you turned it on. We raised the log level to debug and captured the backend actually engaging the patch applying, the speculative backend being selected, and the multi-token prediction path activating for the request, with 3 stages and a draft width of 3. Then we put the log level back before taking a single timing. Because debug logging is itself a measurable drag on throughput, the run that proves a feature is on must not be the run that produces the number. Those are 2 different experiments, and if you merge them, you get a figure that is honest about nothing. Third discipline, then the answer. Our first attempt at a long generation comparison was invalid. 2,000 tokens against 428. Different cache pressure. That is not a delta, it is 2 unrelated facts. So we forced a fixed 800 token generation and ran it twice, 41.5 tokens per second, identical both times. And on the only truly equal length comparison we have, the warm 250 token run, 23.1 up to 34.5, a 49% gain. Now look at the bottom row. The old model was 33.6, so the upgrade is not merely no longer a regression, it is faster than the thing it replaced, and better at agentic work at the same time. The trade-off we had accepted for a full day never had to exist. One more honest note. Across runs on identical settings, we saw 34.5 up to 37.6 run to run variance is real. Quote the range, not your favorite number. That is the good news, and I would like to stop there. But the same afternoon produced two results that were worse than wrong, because both of them looked entirely normal. One was a feature that told us it was working. The other was a test of our own that told us something was broken. Neither statement was true, and neither of them announced itself. We also tried compressing the key value cache to 4 bits to win back some memory. It reported success, and then, on the very next line, it reported that it was disabling itself because this model uses attention sinks and the compression kernels do not support them. Memory before and after was unchanged. Now think about what a normal competent test would have concluded here. You enable it, you measure, you see no change, you write down key value quantization does not help this model. That statement is wrong, it is confidently wrong, and it closes the question because nobody revisits a documented negative result. The truth is that it never ran. Verifying that a feature activated and verifying what it did are different tests, and an outcome test on its own cannot tell the difference between a feature that did nothing useful and a feature that never executed. And this one nearly cost us everything. After enabling speculative decoding, the acceptance gate came back 4 out of 5. The failing check was tool execution, which of all 5 is the one that matters most, because broken tool calls are the exact known risk of speculative decoding. A change that breaks tool calling is a change you revert immediately. We were one decision away from reverting a 49% gain, but the check worked by scanning the log for a particular string and treating its presence as proof a tool had run. That string came from a library that had been swapped out hours earlier during unrelated work. It appeared 0 times, and a tool call we knew had succeeded also produced 0 matching lines. The gate had silently stopped testing anything at all. Rewritten to count executions reported by our own client, it returned 5 out of 5. Here is the general rule, and it is the most portable thing in this video. A test that asserts on a third-party dependency's log output stops testing the moment that dependency's log output stops testing the moment that dependency changes. Assert on your own code's output. And notice that the loud version of this bug is the lucky one. If that string had survived by coincidence, the check would have passed while testing nothing, and it would still be sitting there today. One more, because it changes how you should write every classifier you own. We asked the model which company created DeepSeek v4 Flash under a strict schema whose allowed answers were 3 companies that do not exist, and answered Bumblebee Corp with high confidence. The model knows the real answer. It is in the question. But constrained decoding is not a hint, it is a hard mask, and the correct answer had probability 0 because it was not representable. Look at that second field as well. It said high confidence because the confidence field is just another constrained output of the same process. It cannot audit a constraint that also applies to it. So any enum used for classification must contain an explicit unknown or none option, or it becomes a silent wrong answer generator. Without one, an out-of-distribution input does not produce an error. It produces a confident misclassification that parses cleanly, validates against your schema, and passes every check downstream. What actually shipped was 3 settings, each verified active from the server's own logs rather than assumed. Speculative decoding on, the primary model penned, so it is exempt from eviction and eager loads at startup, and a 30-minute idle timeout for everything else. Throughput up about 50%, and the memory contention that had taken the service down twice in one day is structurally gone. But the settings are not the transferable part. The 3 lessons are: verify that a feature activated, not just what happened afterwards, because a feature can report success and do nothing. Never compare across versions. Rebaseline the old configuration on the new build first, and never let a test assert on somebody else's log output, because the day that dependency changes, your test stops testing and does not tell you. And if you take one practical thing away, go and look at the parameter count on whatever local build you are running. 284 billion means the draft module was thrown away. Low 300s means you have it, and it's probably switched off. Every number in this video with the conditions it was taken under and the caveats that govern it is written up at mtp.novcog.us.com, including the vendor benchmark table, clearly fenced off as unreproduced because we did not reproduce it and neither has anyone else. And if the useful part of this for you was the method rather than the model, the rebaselining, the activation checks, the habit of distrusting your own gate, that is most of what we do inside Hidden State Drift. Weekly working sessions for people who measure their own stack instead of reading about somebody else's. So that is the bench note, a capability that shipped inside the checkpoint, defaults to off, and gets stripped by most community quantisations, worth 49%, and invisible if you never look. 2 features that reported success while doing nothing. 1 test of our own that failed for a reason that had nothing to do with what it was testing. The model got faster, but the thing worth keeping is the measurement discipline, because that transfers to every other number you are about to trust.